Hello students, today we're going to learn section 9.2, data distributions and outliers. A data plot is a way to represent data using a number line and symbols. We usually use X's for the dots. So here is an example of a dot plot. So we have a number line and we use X's to write down how many times these numbers occurred in our data. An outlier is a value in a data set that is much greater or much less than most of the other values. So to find an outlier, what we'll do is we'll take quartile 1 minus 1.5 times the interquartile range. If there is a number in the data that's less than this, it's an outlier. Another outlier might be where we take quartile 3 plus 1.5 times the interquartile range. We've learned this in section 9.1, the interquartile range in quartile 1, 2, and 3. Alright, so if we see this dot plot, this is what we call skewed to the left. So if we drew a graph that's around this data, you can tell that we'll call this the tail of this graph. When the tail is on the left, it's what you call skewed left. This right here, the tail is on the right, so this is skewed right. Sometimes when it's skewed to the left or skewed to the right, these data might be outliers. And when everything is pretty much even, this is what you call symmetric. Alright, so let's do example 1. In example 1, it says Starbucks has 11 employees. Create a dot plot for the salaries. Now the salaries are in thousands of dollars. So for example, one employee makes $40,000, $60,000, $50,000, so forth and so on. Now just like in 9.1, I did mention make sure you rewrite the data in order. So let's rewrite the data in order. It'll just help. So when we rewrite the data in order, the smallest number here is 25, 30, then write 35 twice. There's a 40, and another 40. So 43 times, 45, 50, and 60. So we rewrote the data in order. So these are the salaries that represent the 11 employees from Starbucks. So 11 salaries, and again, these are in thousands of dollars per year. Alright, so what you're going to do is, to make a dot plot, draw a number line. After we draw a number line, space the number line in equal distance. So for example, that's equal distance, so forth and so on. So the spacing is 10. The scale is 10 between each number. The next thing you're going to do is you are going to mark. So when we mark this, there's 25, there's 30, there's 35, there's 40, 40, 40. So 3 people in the company make $40,000 a year. 45, 45, 50, and 60. So we made our data plot. That's all you have to do for example 1, part A. We are done. So again, the data plot is when you have a number line and dots to represent the data. Please make sure that these are equal between each number. Okay. So part B, it says now suppose the owner's salary is part of the data. The owner makes $150,000 per year. is the salary an outlier. So let's check if the owner's salary is an outlier. So what we're going to do is we're going to write the same order, but now we're including the owner's salary in this. So to check this using the formula, what we're going to do is find quartile 2, the median. So we start from here. So I notice there's two numbers in the middle. So when there's two numbers in the middle, we're going to add the 2 and divide by 2. So 40, that is quartile 2. To find quartile 1, what we're going to do is, this is our quartile 2, this right here. So we're going to count from here, 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 and here. So there's two numbers in the middle again. So let's when you take 35 plus 35 is 70, divided by 2 is 35. So this is quartile 1. To find quartile 3, we don't include quartile 2, so we start counting here. So we count this way. So this is 45 plus 50 over 2. And that's going to end up being 47.5 is quartile 3. So notice 47.5 is between 45 and 50. Alright, so now the IQR. The IQR, remember, inner quartile range is equal to quartile 3 minus quartile 1. And that's going to be 47.5 minus 35. So 47.5 minus 30.5, I'm sorry, 47.5 minus 35 is 12.5. So that's the IQR. So what we're going to do with this is we're going to use the formula. So remember, the formula from the front was this here. So I'm going to use these formulas and check if we have an outlier. So let's take Q3 plus 1.5 times the IQR. So Q3, what is Q3 again? 47.5 plus 1.5 times the IQR is 12.5. So when we get the calculator, we could take 47.5 plus 1.5 times 12.5. That equals 66.25. So let's check. Are there any numbers greater than 66.25? And it's right here. So 150 is an outlier. Now let's check for the lower outlier. This is the upper outlier. Let's check for the lower outlier. The lower outlier was Q1 minus 1.5 times the IQR. So Q1 is 35 minus 1.5 times 12.5. So let's take a look at this. So when you get your calculator, it's going to be 35 minus 1.5 times 12.5. That equals 16.25. So all of this is 16.25. Now, are there any other numbers lower than 16.25? No. The lowest number is 25. So there's no lower outlier, there's an upper outlier. So 150 is an outlier. All right. So if we were to look at a graph, we can just easily do this. So I'm just going to roughly draw this data set. So if this was 20, 30, 40, 50, 60, 70, all the way to 150, all the data, if you recall this, all the data is here. So I'm just copying this here. And 150 is out here. So if we look at this curve, this is skewed to the right, and notice this is really far apart from where all the data is. So visually you could see that 150 is an outlier. Alright, that's the next thing we would do for the new, let's say part C is, suppose a new employee is hired at $15,000 per year. Is the new employee's salary an outlier? Do not include owner. Okay, don't include owner in this. So what I did was I rewrote the data, but now I rewrote the new employee. So this is the new employee, this person here. So again, we just do the same thing. We find quartile 2, so count from the first and the last and go towards the middle. So there's 2. So we already know that. That's going to be 40, and that's quartile 2. We already know from here. So we don't count this quartile, we start counting here. So here, here, and here, so that's going to be 45, quartile 3. We don't start from quartile 2, we count here. So here, here, and here. So this is going to be 30 plus 35 over 2. So just get your calculator. 30 plus 35 divided by 2. This is 32.5. So this is quartile 1. So we have quartile 1, quartile 2, quartile 3. So we apply the same process. Let's find the IQR. That's quartile 3 minus quartile 1. 45 minus 32.5. So 45 minus 32.5 equals 12.5. Now, we know from here we are not going to have an outlier at the right, but we might have an outlier on the left because this is now 10. So let's see if that's an outlier. Alright, so to find the outlier, we'll use this formula. We'll use quartile 1 minus, formula is here, quartile 1 minus 1.5 times 12.5. So when we take all that in consideration, this is 32.5 minus 1.5 times 12.5. So 32.5 minus 1.5. So this is now 13.75. So this is the lower quartile barrier, if you will. So are there any numbers lower than 13.75? Well, yes, 10. So 10 is an outlier. All right, that's it for today. Have a good day.